All right, beautiful people. So today we're talking about what operations we've already learned about polynomials. So we're going to cover some addition, subtraction, and multiplication. But the first thing I want us to do is we're going to recall what the word polynomial means. A polynomial is an algebraic expression with one or more terms. So, and then we'll recall from before, we call each of these terms monomials. So here's an example of a polynomial, ex. So I usually do examples right underneath the definition. We have 2x cubed plus x squared minus 5x minus 3, let's say. So this is a polynomial because it's got more than, it's got a few terms in an algebraic expression. Okay, another example of a polynomial would be something like 4x to the second power, 4x squared. They're both polynomials. Okay, you do not have to have more than one term in order to be a polynomial. All right, some important things to note about polynomials is that they don't need coefficients. Like you could have a polynomial that only has an x term. Sorry, you guys. Sometimes my words. So this right here is called the lead coefficient because it's attached to the variable with the highest exponent. Okay, so this is also a lead coefficient because, again, it's attached to the variable with the highest exponent. But these numbers could be in any order as long as the lead coefficient is attached to the variable with the highest order. Which brings me to my next point, that a degree is the highest or largest exponent in a polynomial. So for this first one, our degree is 3. For the second one, our degree is 2. Your degree depends on what the biggest power exponent variable is in that polynomial. Okay. And then last but not least, I want to talk about what a binomial is. A binomial. So you may have noticed that polynomial, poly means multiple, bi means 2. So a binomial is a polynomial with just 2 terms. Again, make sure you're pausing to write these definitions down, and also putting examples if you don't understand it, or maybe not writing things that you do understand. So here's an example of a binomial: 2x plus 3, 5 plus x, okay, 15y to the third power minus 6. All these are binomials because they've just got 2 terms in them, and they're usually added or subtracted together. All right, so we'll begin this exploration of operations with polynomials with addition and subtraction. So our first example I'm going to do, and let's try green, why not? Okay, so when you add or subtract polynomials, basically all you're doing is combining like terms. So when I think again about like terms, I need to remember that like terms are terms that have the same variable with an exponent. So here I have an x to the third power, here I've got another x to the third power. Here I've got an x to the second power, here I've got another x to the second power. Here I've got an x to the first power. I don't have any others. And last but not least, here I have a 1, like just a constant. So then I'm going to combine like terms. But the first thing I want to do is make sure that I get rid of the parentheses. So if there's distributive property to be done, then I'm going to distribute it. But since this is addition, I'm basically just multiplying a positive 1 to each term. So this can be rewritten as 2x to the third power minus 5x squared plus x plus 2x squared plus 3x to the third minus 1. Notice when I rewrote it with those colors that I had already designated. I know that some of you don't have colored pencils or whatever to do. That's fine. You should indicate somehow that these terms were going to combine together. So I'm going to start with my x to the third power. So I've got 2x to the third power plus 1x to the third power. Because remember, if I have a variable without a coefficient, there's an invisible 1 there. So total, I have 3x to the third power. Okay, now I'm done with those. I'm going to go on to the x squared problems. I have a negative 5x squared and a positive 2x squared, which leaves me with negative 3x squared. Okay, I have an x term, which doesn't have anything else, so I do plus x. And I have a constant that, again, does not have anything else, so I leave it with minus 1 at the end. And here I have added my